Until now we had our squares equal spaced, drawn on the screen with equal spacing, and we want to set a variable amount of distance between each square. So instead of using the value 10 or 20, we want each one of our larger squares to be further away from each other. So how can we assess this? We first of all have our regular square drawing function, and we have the regular moving turtle to a location, but with a distinction that we have a variable, a parameter in our move turtle back function. In the earlier version we didn't have such a variable. Let's compare it with the older version first. So in our previous implementation, all these squares were equally spaced, and move turtle back function did not have any parameters, as you can see. But in the next example we have the same function which is doing the exact same operation, but it has a parameter named square spacing, which is used in both horizontal and vertical spacing, which we achieve by moving our turtle and turning it to a specific degree. And then in order to call this function from the draw a square and move back function in our previous examples, we need a spacing value, the space between squares, which is a variable, which is actually a parameter received by this draw a square and move back function, and then this value is passed directly to the move turtle back function, which is then used in its own implementation to pass that value to the turtle forward or turtle backward methods. So if we simply put it in an order of calls, first let me move this a little bit down. So the first call to draw a square and move back function receives a value from a variable named spacing, which is initially set to 10, and then this variable is passed to this function, draw a square and move back function. Its name changes. It doesn't have to, but it can change. So this means that they don't have to have the same naming. This is spacing here as a variable in the main body of the function, and when this draw a square and move back function is called, it is set as a parameter to that function call, and the function is called. So the third argument, first one is red, second one is size, and the third argument is spacing. So the first one is square color, second one is expected to be the size of the square, and the third one is going to be the space between squares. So its name will be space between squares. So the naming doesn't matter, but it has to be consistent within this function. So spacing has to be consistent within this execution flow of our application. So in this scope, this is a scope. is a code scope. This is another scope. Okay, we will talk about those scopes later. In this scope, we have to use the same naming. When we come to the function scope, we renamed it, or we changed the name, space between squares. So it receives the value 10. And this value is passed on to this part, move turtle back, as the value 10. So when it comes to move turtle back function, this is our function. It changed its name once again. You might use the same naming, it's okay. But when you change the name, it just takes the value sent from this draw a square and move back, which was 10 initially. This 10 was passed on to this function call, and it was when you pass it, this function definition is materialized, if you may. It is put into execution with the value 10 for space between squares, and this space between squares is perceived as square spacing in move turtle back function, and the value is 10, so it is passed on to the turtle function, okay, having the value 10 at each case. And when we change this, when we change all these, let me clean this mess up first. Okay, when we change the value of our spacing variable, as in this case, okay, what happens is we add the value 5 to the current value of our spacing, and it becomes 15. And the next call to our draw a square and move back function is called with the value 15 for spacing. Okay, when we pass this to space between squares, it becomes 15 in this call, in this instance of this instantiation, if you like it, of this function definition. So it's not this is just a prototype. Let's say when you make a call to that function, as in this case, typing the name of the function and providing the attribute it requires, the parameters it requires, the function starts executing with the value 15 for space between squares. Also, the square color is blue in this case, as you see, and the size is calculated as size to be size plus 2 times spacing. So whenever we change our spacing, we also add the twice as much amount to the size, twice as much spacing to the current size, and use that value as the current size of the new square. And when we call this draw a square and move back function with the value 15 set as the space between squares, this value is passed on to move turtle back, and turtle is going to move back as much as 15, because this is the only parameter it receives from the calling statement, and it is 15. So we have changed this value over and over in the statements, in the instructions below. So each one of these values that we contain in our code, that we pass to our functions, are called variables. Variables can hold different values that you can recalculate over and over and use in your code, and the variable itself can be modified by other parts of your application. So they are actually containers of data They can be complex types or simple types, such as an integer or a floating point number, a decimal number. They can contain strings. They can also have more complex types, which we will discuss later. However, there is a distinction with Python and the other major object-oriented programming languages. Python does not state the type of variables in definition time, so it's not a strongly typed language. The variable type is not defined when you first initialized it here. So we just set a variable and placed 100 into the variable and spacing, and we placed 10 into the variable. There could be something like this: color equals red. Now this variable is going to hold a string variable. Okay, so the definition is same. You just write the name of the variable on the left hand side of the assignment operator, which is the equals sign. Okay, this is called the equals is assignment operator. So when you put a variable name on the left hand side of the assignment operator and the value such as a number or a string on the right hand side, that variable is going to be declared or defined if it doesn't exist in the computer's memory yet. If it exists, if it was defined before, the value is going to be changed by the new assignment. So if I assign color equals 150, the type of this color variable is going to change. It's going to become an integer, but it was a string in this case in the first assignment. So if you need to know the type of your variable, you simply use the type function of Python, where you can, okay, I need to find an easier way of cleaning this drawing screen. Let me see if I can do this. Just a second. So it's a new thing for me too. Okay. So when you want to look up the type of your variable in your hand, because it might be changed by some other part of the code, and you might not know at which order it's going to change, you might simply write this type function and place the variable in it, and it's going to display variable is of type class int, class str, which means string, class float, and class bool. Bools are booleans, as you know. They can contain the value true or false, either of them, nothing more. And the integer can contain whole numbers. They cannot contain decimal numbers. Floats can contain decimals such as 10.3, etc. Integers can only be 100, 1, 2 million, etc. But they cannot contain any decimal point. Strings, as you know, are the text that we have included in our code within quotation marks, such as red, such as CMP 150, etc. And Boolean can only be true or false, as in this case. We will come to them later. So let me scroll down a little bit. So variable naming is similar to function naming. It cannot start with a number. It can contain numbers, but cannot start with a number. You cannot have a star plus minus or other types of special symbols in a variable name or a function name. So they are also case sensitive. You cannot use the age variable and a variable name age, and you cannot use it interchangeable with the age or age with different letters being capitalized. Also, a good coding convention is that your variables should indicate what the purpose of this variable might be. Of course, it can change, but you should generally stick onto the variable's purpose and use other variables if you have other purposes. It's not a good practice to mix integer variables with strings or using name as age, etc. So, as a good coding convention for your well-being, you should stick to the purpose of your variable, and the name of the variable should give a clue both to you and other people who are going to inspect your code maybe. There are some reserved words in Python that you cannot use as variables or functions. So the keyword and, for instance, you cannot have a variable named and or elif or else, any of these. These are reserved words, but this might change from the version of the Python installation that you have running on your computer. They don't change every day, but there may be new inclusions, new keywords added to a Python version. If you have Python version 3, you might have these keywords. If there comes a Python version 4 one day, some additions may be included here. So the compatibility of your program depends on these factors as well. You might have had some variable name called jump, okay, in your program, and one day a Python version may show up with a keyword jump. So this is going to cause an error on your program. You would have to replace this jump, these variables named jump, with some other variable name so that it doesn't collide with the keywords of Python. This is one simple way of putting it, but there might be many other compatibility issues other than just function and variable naming. So you can check which ones are present in that environment, in that Python version. You might implement your code using a specific Python version, and the client might have other Python versions installed. So you should be checking the versions and the keywords if they are compatible before letting people use your code. And you can also find which are available typing help keywords on your terminal command prompt. So I was talking about these assignment statements in Python. As in the previous example, we had size equals 100, which was a variable on the left hand side of the assignment operator to receive the value 100. Also, size can be modified, reassigned with a new value calculated on the right hand side. So if there is something on the right hand side of an assignment, that expression is evaluated first, and then the result is assigned to the variable on the left hand side. So we obtain a value from the right hand side and assign that value to the left hand side. This is the order of execution and an assignment operation. So when we are dealing with numbers, it's okay. We just calculate the value. How about dealing with strings? What does it mean to add a string to another string? It is simply putting together strings back to back, and the result is going to be BOUN 102 or CMP 150, whichever strings you have here. You can have as many strings as you like, as you need to be concatenated. It doesn't make sense to concatenate these strings together. We could just type it in as in the line above, but if we are dealing with variables containing different values such as name and last name of students or people, it would make sense to concatenate them, add them together, and obtain a new variable with the concatenated string. You can also assign multiple variables at the same time. They're going to receive these values in the order given on the right hand side. So A will have 100, B will contain 450 as their values. Also, you can have three variables at the same time, C, D, E, having variable values 200, 250, and 300 respectively. You can also get these printed out on your terminal. You can also assign variables to the values of new variables, other variables. So F will receive the same value of A, and G will receive the same value of D. If they are simple types, they are going to receive the values, but if they are complex variables, they're going to be pointing to the same location in memory. We're going to talk about that as well. Simply you can reassign the values. So if a variable is not present in your computer memory at a time, when you assign it, it's going to be initialized with the given value. Also, you can swap the values of two variables, A, B, B, A. So if you do it in one statement, Python is going to keep their current values in its mind. And let me do this with an example. I think I had something here. Okay, so I had my A variable to be A is 100, B is 200, and if I print A and I print B, program is going to first display 100 and 200, and if I assign A to B and then if I assign B to A, do you think it is going to serve the purpose of swapping their values? Just think about it as I type. Okay, let's rerun this main. So it first displayed 100 as the value of A and 200 as the value of B. And the second time I want it to print the value of A, it displays 200, which was the value of B. But when I want to print the new value of B, it is again 200, because in this statement, Python assigns the same value to A. And when you assign the value from A to B, it's going to be 200 as well. However, if you make this assignment in a single statement, A comma B equals B comma A, without the need of the next line. It's going to simply swap those values and display the correct value for B, which was the initial value of A. This is a shortcut in Python that you can use to swap the values or exchange the values of variables. You can also have multiple variables that can receive the values from other variables or numbers. This is still going to work. Okay. I haven't displayed the value of C, but you got my point. And it locked me out. Let me log in once again. Okay, fast forward. Functions, variables, assignment statements. And I think we covered this part as well. In the earlier example here, if you wanted to swap the values of two variables to be a equals b and b equals a, we have to use another a equals before we change the value of b, we need to assign it to another variable named temp maybe, and before making this exchange, let's just park the value of a into temp and assign the value of a to b to a, sorry. I have now saved the value of a. I can overwrite it with the value of b. And now I know I need to write the previous value of a to b, which was stored in temp. So this is actually 3 statement long exchange, but you can do it in a single statement, ab equals ba. So this is one fantastic way of Python programming language. There are other assignment operators other than the equals sign. Equals sign, when used in a statement like this, is the assignment operator. So x becomes 2. If you use the increment operator, plus equals, it's going to increment the value of the variable with the given amount. So a plus equals 5 will make a to become 105, okay, as in this case. So if I reprint a, it's going to display 105, sorry, 105. As you see, if you use the decrement operator, which is minus equals 5, it's going to reduce the value of your variable. I have accidentally inserted a space between the minus and equals signs. This has broken my code. It says there's no such operator. So they have to go together. There's no spaces in between these two operators, plus equals, minus equals, or multiplication equals, let's say. The multiplication sign is the asterisk on your computer, which is next to the 0 on my keyboard. Might be somewhere else on yours, but if you're using a Turkish layout as I do, you're going to find it next to 0. So the x sign is not used for multiplication as it is in mathematics. Instead, we use the asterisk operator for multiplications, and asterisk makes your variable to be multiplied with the given value on the right hand side of the assignment operator. So this is in fact equal to a equals a times 10. So if you're not sure how you're going to use it, you can simply write it this way. It's going to take the current value of a, multiply it by 10, and then assign the calculated result on the right hand side of this assignment expression, and assign this value to the left hand side, which is a itself. You can also assign it to other values if you write it this way, but the shortcut notation tells us that a is going to be multiplied with 10, and that resulting value is going to be stored in a itself. Division is straightforward. One thing that you might have not encountered yet is the modulus operator, which is the remainder of a value from division by the given number. So if I take a mod 10, a mod equals 10, it's going to take the value of 10, take the value of a, divide it by 10, assign the remainder to the value in the a variable, and if we take a look at it, a is 100 initially, we reduced 5, displayed the output, and we take the modulo 10, the remainder 10, the remainder of 95 divided by 10 is 5, so it displayed it calculated 5 and stored it in a. Then we can use the variable a to display the value. Floor division is used for obtaining integer results from divisions without any decimal parts, and power is 2 stars followed by an equal sign. So you can raise a variable to the given power on the right hand side.